Hello, everyone. Robert Saunders here, and I'm here with one of my good friends, Saeed. He's in our solutions engineering team. And we did this demo, which is really cool. It's around APEX Block Storage and multi-AZ storage resilience with SQL Server. Now, it's not necessarily a SQL Server performance exercise. It's a storage resilience exercise, and you'll see why we use SQL Server. Both Saeed and myself were big SQL Server gearheads, so we said, you know what, let's use SQL Server and prove it out that it works. And it's really, really cool. We wanted to get this on tape. So let's get started. So first off, the simulation architecture here. And for those who don't know, Dell APEX Block Storage can be deployed to AWS. It can be deployed to Azure. And what we did here, and Saeed set all this up, which was awesome, we did 3 different availability zones. You see AZ1A, AZ1B, and AZ1C, but it's a single Dell APEX Block Storage cluster spread across all 3 of those availability zones. Talk about resiliency. That's very cool. Saeed, any thoughts here?
So what we have here is the 6 SDSs, that the storage data servers, and those are going to provide a local storage. And what you see is SQL. On top of it, we have SDCs. They map the backend volumes to the application, and we have spread across 3 availability zones, so that in case of a failure of any of the zone, we would not get affected during the application, would work as seamlessly as it has to.
Yeah, and then we use, you're going to see here, and you see right there on the screen, we use HammerDB. And the cool thing about using HammerDB, well, SQL people love it, so we both love it, but it's also really picky. If a connection drops, it will stop really quickly. So that's why it was kind of really cool to use this. So let's kind of dig into here. So of course, that's 1 cluster across 3. That's what you just talked about there, Saeed, the SDSs and the failover cluster instances with the shared storage. And this is what we're going to do. We're going to simulate an AZ failure by stopping the SDS instances in a single AZ, which simulates the failure of the entire AZ going down. That's how we're going to simulate it. And you're going to see that SQL Server with HammerDB as a workload remains resilient. This is very cool. So, of course, we have SQL Server running, and of course, we ran it with the latest and greatest SQL Server 2022. There's TPCC working, SQL Server 2022. This is our jump host, and of course, TPCC work, orders being generated. Orders are processing. For those who know HammerDB, the orders line is just churning through records and writing in rows. So, and then of course, we have HammerDB running, SSMS, activity monitor, also logging work, just a few different ways to show work being generated. TPM's going. Now remember, TPM's just average right now. These machines, Saeed, help me out here. I can't remember the actual CPU and memory for this machines. We didn't really go crazy with these SQL servers, did we?
No, we were with 16 vCPUs and 64 gig of memory. We didn't really go with a larger configuration.
Yeah, and that's fine. Again, it was about storage resilience, and SQL Server just happened to be the workload we wanted to showcase. So there's the failover cluster instances.
Right, so we have configured database to CSV files on the Windows side.
Yep, that's right. Yeah, we'll show that here just in a second too, which is really good. I think a lot of people are going to like that for sure. So here's the PowerFlex Manager, where we can browse to the volumes, and right there, Saeed, like you were talking about, there's the CSVs on the PowerFlex side that are shared with the 3 SDCs. Now, we talked about this earlier. The SDC, or the storage data client, that is how you consume APEX Block Storage in the cloud. Saeed, any thoughts on that?
So the SDC is going to map the volumes on the storage, and that's where the application is going to see the volumes.
Yep. So that's how how APEX Block Storage can run in the cloud and how you can consume it. It's not directly a drop down from maybe AWS or even Azure. It's just you're consuming with the SDC that would be installed on the workload host. So there's the SDCs. There's the host IP that's consuming that storage. Now let's go back over to the SQL location. There's the volumes. Everybody knows this path from a SQL perspective all the way down to data. And there's my TPCC 150 gigabyte data file residing there as part of that shared storage. So back over to PowerFlex Manager. Again, this is the interface. We see work being generated. We can go into details here. And this is looking at our APEX Block Storage that was deployed, again, into AWS. So a few different windows here between AWS and PowerFlex Manager, but we're looking at the instances that are up in AWS. The MDM, the metadata manager, which is managing all of the internal storage config. There's the SDS instances, and there again is the SDC SQL instance storage instances. Back over to SQL again. I know I'm going back and forth, but kind of showing this here. So now we're ready to start the simulation. Right there, you see, well, let me build it out just a little bit farther. There's our 3 availability zones. We have 2 instances, 2 in C, 2 in B, and 2 in D. And that bottom one is just the installer, right, Saeed? That's how, and that one can actually be turned off if we didn't do it, but that's not part of the cluster, correct?
That's right.
Yep, yep. So what we want to do is simulate a failure. So I'm going to go into one of the nodes or one of the instances, and I'm just going to stop it.
Right.
Not hiding that, right? I'm going to stop that one. There it's stopping or successfully stopped. And I'm going to stop the second one. Uh-oh. Now what's going to happen?
Oh, you should be seeing a lot of disconnects.
The tension mounts now, simulating the AZ failure. We see stopping, so both instances in AZ1C are down, simulating the failure.
Wow.
Yep. So this is interesting here. So let's talk about this. We do see a dip, which is what we expected.
That's right.
But the workload remained resilient. We're still generating work. HammerDB is still working. SQL Server is still churning along. But I wrote here, and Saeed, you can expand on it. The rebuild takes priority to re-protect this data because we just lost 2 nodes. And we always want to have 2 copies of data spread across the SDSs all the time. So Saeed, go ahead and expand upon that a little.
So once you power down, the way we see the dip is, in the back end, you would see there will be rebalancing activity which has been taken place. So the back end, the system is rebalancing all the drives and data. Hence, you're looking at this dip. This should not take a long. We should get back to normal.
Yeah.
Once the rebuild activity completes.
And you'll see that we do get back to normal here in a few. And I would argue that I bet the application or the users don't even really experience much of a dip, right? Because we're still churning here. And of course, I'll jump back through some of the SMS or SSMS screens. Work is continuing. Of course, I have to hit F5 a bunch of times. Back over to PowerFlex Manager, and we can see we got some alerts because we did some things. There's a little bit of that dip right there, so we logged it there too. Back over to SQL. The cluster quorum is healthy still. That's a good thing. Now, watch this. The TPMs are going to slowly come back up here. And this is about 30 seconds, like Saeed said. We'll start creeping back up to 100,000, kind of where we were before we even started the test, but now we're running with 4 nodes or 4 instances. So that right there is super cool. We never lost connectivity with HammerDB. We talked about that. So now let's return those SDSs back to the storage pool. We're going to start them, kind of doing the opposite of what we did, just to bring them back in. There's a few more things I want to show here on the PowerFlex graph. So we can see that the performance return there. Now, right here, and we'll talk about this for a second, Saeed, this is super interesting because that spike is where we stop the instances, correct?
That's right. The moment we stop the instances, you see the latency is really peaked high. But then if you keep watching that, the latency is getting back to normal as the rebuild is taking place. And once the rebuild is complete, you see the latency back to normal.
Yeah. Yeah. And it took, well, just like we logged, about 30 seconds. Because remember, that rebuild would take priority. Protecting data takes priority. So
that's right.
That's super cool to see that little step graph there. So we have all the instances running again. Of course, we see that performance returned back with 4. We see our workload remains constant, even a little better. And of course, a rebalance has started.
Right.
So that's kind of the demo. I mean, that was super cool. All the nodes are healthy, or all the instances. So that's the demo. Any last thoughts, Saeed, or any other conversations or interesting facts that you thought about when you were doing the demo or working through this?
So the only one experience I had was we need to configure a fault set. Without that, you would see some sort of a disconnects.
Right. So it really comes out like we showed at the very beginning of the architecture. It's a one-to-one with fault set and availability zone.
That's right.
Right. We had 3 AZs, so we have 3 fault sets. That's the way it works. Excellent. Well, thanks, Saeed, for joining me. Awesome job with putting together the architecture. It was really fun to go in there and get all this recorded, and we're going to do another one, I guarantee you.
So
thank you.
looking forward. Thank you.